This begins lesson 4.6, part B. Yesterday we discussed complex numbers, and we said that any number can be written as a complex number. For example, just for a brief review, the number 3 is a real number. It can be written as a complex number if I'd said plus 0i. So in other words, 3 is a complex number with a 0 value for the imaginary part. I could write 2i, which is imaginary, and write that as a complex number by putting a 0 where the real number should go. Today we're going to focus on the imaginary part. We said yesterday that if we have a square root of a number, it's equal to I. Or in other words, the square root of -1 is equal to I. We had an example of the square root of -4. That is 2i. Square root of 4 is 2, but to take care of the negative, we have to have an I. The square root of a -2, you can't root 2, but you can bring the I out. So in other words, if you have a negative in a root, bring the negative out and put an I in front, and that takes care of the negative. So if we look at our examples here, number 1, we have a negative in there, so we're going to have an I. 19 we cannot root or simplify, so this is our answer. Okay, that's what this says right here. The negative comes out as an I, and you keep whatever's in there underneath the root if you can't simplify it. Number 2, this is a distribution of a power. So 2 to the third power, I to the third power. 2 to the third power is 8. And the question is, how do we take care of I to the third? We've already talked about this, that the square root of a -1 is equal to I. This is the new part we're going to talk about. I squared is equal to -1. There's also one more that I want to share with you, and that is that if I squared is equal to -1, then I to the fourth is the same as, oops, I got a T there. I don't know where that came from. Sorry about that. If I have I to the fourth, that's the same as I squared. Well, we know that I squared is equal to -1. I just told you that. So this is the same as -1 times -1, which is 1. So in other words, I to the fourth is equal to 1. Positive 1, and that's important. Okay, and we'll see why. Now these two things will help us simplify problems with I in it. If we have I to the third, we do not have anything to simplify or to talk about how to simplify that, but we can say that that's the same as 8I squared I. These two add up to 3. Now why is that important? Because we know that I squared is -1. In other words, we have -8I. A finished answer should only have an I present. It should not have anything higher than a power of 1. If it does, then you haven't simplified far enough. Let's take a look at number 3, I to the 9th. We could look at this as I squared, I squared, I squared, I squared, I. That's 1, 2, 4, 6, 8, and one more is 9. Each one of those I squareds is equal to -1. So it's like saying -1 times negative 1 times negative 1 times negative 1 times I. That's equal to 1. That's equal to 1. So the answer is just I. That's a lot of writing. And that's why I showed you I to the 4th. If you have I to the 9th, and you say how many times can 4 go into 9? 4 can go into 9 twice. Okay? With 1 left over. That's 9. I to the 4th raised to the 2nd power is the same as I to the 8th. Now I write it this way because what do we know that I 4th is equal to? 1. And again, that's equal to I, because 1 squared is 1. That's going to take a little bit of practice to understand how the I can be simplified, but it is not as difficult as one may seem at first glance. If we have this problem, we're multiplying, which gives us 27 I squared. We said that I squared is equal to a negative 1, so our answer is negative. Sorry about that. So our answer is negative 27. Now look at this. We have two binomials, or two complex numbers being subtracted. Now be careful. If this was a plus sign, we can just drop the parentheses. But it is not. It's a minus, so we have to accommodate that and say that we must distribute the negative in order to get rid of the parentheses. So that would leave us with 2 plus 6i minus 1 plus 3i without parentheses. The good news about I, if you haven't felt that there's been much up to this point, is that when it comes to combining like terms with addition and subtraction, you would approach it as if they were variables. In other words, combine like terms. So if you have numbers that do not have I, you put them together. 2 minus 1 is 1. If you have numbers that do have I with them, combine them as if they were like terms. So 6i plus 3i is 9i. And that is your answer. If they are not considered like terms if a number has an I with it and one doesn't. Remember, they represent the real part and the imaginary part. Now, unlike this, where you have things being subtracted or added, here we have multiplication, which is FOIL. First times first, outside, inside, last. So first times first would give us 24. Outside is negative 54i. Inside is positive 12i. And last is negative 27i squared. Now, we know that the two middle terms have I, so they're like terms. Negative 54 plus 12 would give us a negative 42i minus 27i squared. Now we have an I squared. Remember, that's the same as a negative 1. So this is 24 minus 42i. Negative 27 times a negative 1, that's what I squared is equal to, will give you a positive 27. And in doing so, we now have some like terms again. 24 plus 27 is 51 minus 42i. At this time, I'm going to stop, and I will finish your lesson in part C.